First, we create our node class. Every node has two parts: data, which stores the value, and next, which stores the memory address of the next node. Now we create our first node, head equal to node 10. As soon as this line runs, Python creates a node object in memory. The data field stores 10, but the next field is none because we haven't linked it to anything yet. Next, we create more nodes. N2 equal to node 20, N3 equal to node 30, N4 is node 40, and N5 is node 50. Now we have 5 separate node objects, each living at different memory locations. At this point, every next field is still none. Now comes the interesting part. Head.next equal to N2. As soon as this line runs, the next field inside the head node is updated with N2's memory address. It no longer points to none. Then we do the same thing again. N2.next equal to N3, N3.next equal to N4, and N4.next equal to N5. Each line updates the next field with the memory address of the following node, creating a chain. And that's exactly how a linked list works. Every node stores its own data and the address of the next node. Why is insertion so fast in a linked list? Because we don't have to shift every element like an array. We simply change a few pointers. Now, let's insert a new node N6 after N2. First, we create the node N6 equal to node 60. As soon as this line executes, Python allocates a new node object in memory. It stores the value 60, and its next pointer is initially none. Next, we write N6.next equal to N2.next. At this moment, N2.next is pointing to N3, so now N6 also points to N3. Finally, we update N2.next equal to N6. Now, N2 points to N6, and N6 points to N3. That's it! We inserted a new node in the middle without moving any other nodes. Deleting a node in a linked list is also fast because we don't move any nodes. We simply change one pointer. Let's delete N4. First, we get the next node after N4 by using temp equal to N4.next. So now, temp is pointing to N5. Next, we update N3.next equal to temp. Now N3 skips N4 and directly points to N5. Finally, we write del N4. The N4 node is no longer part of the linked list, and that's how node deletion works. Just update one pointer and remove the node. Now, let's search for the value 40 in the linked list. We start with current equal to head, so current points to the first node. Next, the while loop keeps running until current becomes none, which means we've reached the end of the linked list. In every iteration, we compare current.data with 40. If it matches, we stop the loop because we found the element. Otherwise, we move to the next node using current equal to current.next. The disadvantage is that in linked list is, to find an element, we have to check nodes one by one, so in the worst case, we may need to traverse the entire linked list.